We're going to be drawing Bohr models. Bohr models are models of atoms that show how many protons there are in the nucleus, how many neutrons there are in the nucleus, and then how many electrons there are orbiting around the nucleus. The general format for Bohr models is you have the nucleus in the center, and then around the nucleus are the energy levels where the electrons are. Now, we're going to be concerned with 3 energy levels usually. Electrons have different amounts of energy. The more energy they have, the further out away from the nucleus they orbit. So we have the inner energy level, which is the first energy level. The first energy level is able to hold 2 electrons maximum. Once it has 2 electrons in it, the first energy level is full. Any additional electrons need to be added to the next energy level out. That's the second energy level. The second energy level can hold 8 electrons maximum. When the second energy level is full, electrons need to be added to the third energy level, which is the highest energy level that we're going to be taking a look at usually, and it's the third energy level also can hold 8 electrons maximum. So 2, 8, and 8. Right? This is the basic structure of a Bohr model. So let's do a specific example. Let's do an example of oxygen. To be able to do a Bohr model of oxygen, let's do an example of oxygen. To be able to do a Bohr model of oxygen, we need to know how many protons, neutrons, and electrons there are in an atom of oxygen. As we saw before, you can use the periodic table, the blocks on the periodic table, to find out how many protons, neutrons, and electrons there are in every element. From that, we found out that there's 8 protons in the nucleus of an oxygen atom. Therefore, there's 8 electrons orbiting around the nucleus. The number of protons and the number of electrons will always be the same. To find the number of neutrons, as you remember, we have to do some math. We subtract the atomic number from the mass number, and that will give us the number of neutrons. In this case, it just so happens to also be 8, but that's not always the case. The number of neutrons is not always the same as the number of protons. So to draw the Bohr model, we're going to start with the nucleus. And into the nucleus, I want to write how many protons and how many neutrons we have. So we have 8 protons, and we have 8 neutrons. Now I'm going to make my first energy level. I have 8 electrons that I need to put into the energy levels in oxygen. I can only put 2 in the first energy level, so I'm going to add my 2 to the first energy level. That leaves 6 more to go into the next energy level. So I can draw the second energy level here. This energy level needs to contain 6 electrons. We're going to add them in a very specific way, though. To add electrons, we're going to start up here at the top and then we're going to go around clockwise like this, adding 1 electron to each of the 4 sides, top, right, bottom, and left, before we start doubling the electrons up. So 6 more electrons need to go in here. I'll put the first electron there, second, third, fourth. Now I'm going to start doubling them up. There's the 5th electron in this energy level, and then there's the 6th and last electron in this energy level. If we count up the number of electrons, we get a total number of electrons being 8. So this is the Bohr model for oxygen. Let's do another example. We'll do something bigger, a little more difficult. Let's do a Bohr model of sodium. In order to be able to do the Bohr model of sodium, we need to know the number of protons, we need to know the number of neutrons, and we need to know the number of electrons. This information we can get from the periodic table. If you look at a periodic table, it can be a little tricky to find sodium. That's because the symbol for sodium is Na. If you look at the block for sodium, there's 2 numbers. The smaller of the 2 numbers is 11. That's the atomic number. That tells you how many protons there are. So there's 11 protons. It also tells you how many electrons there are. There's 11 electrons. To get the number of neutrons, you have to do some math. You have to take a look at the atomic mass. That's the number, the larger number. You have to round that to the nearest whole number. The atomic mass for sodium is 22.99. Atomic mass units. So we need to round that to the nearest whole number. So we're going to round that to 23. And this number right here is our mass number. Remember, that mass number tells us how many subatomic particles there are in the nucleus. There's 23 subatomic particles in the nucleus. 11 of them are protons. So the question is, how many are neutrons? So we have 23 atomic particles in the nucleus. We subtract away the 11. And we end up with 12. So this is 12 neutrons. So the number of neutrons is 12. So let's draw the Bohr model for sodium. I'm going to draw the nucleus. Inside the nucleus, I'm going to put the number of protons, and I'm going to put the number of neutrons. 11 protons, 12 neutrons. We have to put 11 electrons in here somewhere. We'll start with the first energy level. The first energy level can hold 2 electrons. So there's our 2 electrons for the first energy level. Now we need to draw a second energy level, and we're going to start adding electrons to the second energy level. Remember, we're going to start up here. We're going to go counterclockwise around. So I have 2 electrons so far. This is going to be 3, 4, 5, 6, adding 1 to each side. And then I'm going to start to double them up. 7, 8, 9, 10. And when I get here, I now have 8 electrons in this second energy level. The second energy level is full. But I only have 10 electrons that I've added so far. I need to add 1 more electron. To be able to add 1 more electron, I have to add another energy level. And again, I start up at the top here, and I add 1 electron to the third energy level here. And this now gives me a total of 11 electrons, 2 in the first energy level, 8 in the second energy level, and 1 in the third energy level. So That's the Bohr model for sodium.